Welcome to our YouTube channel. Our today topic is rules of inference. This is the mathematical logic unit first is going on. What are rules of inference? 4. Mathematical logic is often used for logical proofs. Proofs are valid arguments that determine the truth values of mathematical statements. An argument is a sequence of statements. The last statement is the conclusion, and all its preceding statements are called premises or hypotheses. The symbol read therefore is placed before the conclusion. A valid argument is one where the conclusion follows from the truth values of the premises. Rules of inference provide the template or guidelines for constructing valid arguments from the statements that we already have. Table of rule of inference. This is the rule of inference. This is the name, rule of inference. Rule of inference name is addition, and this is rule of inference. See here. Next is addition. If P is a premise, we can use addition value to derive P or Q in this type of representation. Let's see an example. Let P be the proposition. He studies very hard is true. Therefore, either he studies very hard or he is a very bad student. Here, Q is the proposition. He is a very bad student. This will be like as a P, and this is the Q, and this is OR. So then P or Q. Understand it? Next is conjunction. If P and Q are two premises, we can use conjunction rule to derive P and Q. This is the end. Let P, he studies very hard. Let Q, he is the best boy in the class. Then it will be represented as he studies very hard and he is the best boy in the class. Oh, so not this type of, only this. Next is simplification. If P and Q is a premise, we can use simplification rule to derive P. He studies very hard and he is the best boy in the class. Okay, therefore he studies very hard. Next is modus ponens. If P and P implies QP, P implies Q are two premises, we can use modus ponens to derive Q. For example, if we have a password, then you can log on to Facebook. P implies Q. You have a password P, therefore you can log on to Facebook. Next is modus tollens. If P P implies Q and negation of Q are two premises, we can use modus tollens to derive negation of P. Example, if you have a password, then you can log on to Facebook. P implies Q. You cannot log on to Facebook. You don't have a password. This is the negation. Simple. Disjunctive syllogism. If negation of P and P or Q are two premises, we can use disjunctive syllogism to derive Q. Example, the ice cream is not vanilla flavored. Negation of P. The ice cream is either vanilla flavored or chocolate flavored. Therefore, the ice cream is chocolate flavored. Good. Hypothetical syllogism. If P implies Q or Q implies R are two premises, we can use hypothetical syllogism to derive P implies R. P implies Q, Q implies R. This is the example. If it rains, I shall not go to school. If I don't go to school, I would not need to do homework. Therefore, if it rains, I wouldn't need to do homework. Constructive dilemma. If P implies Q and R implies S are two premises, we can use constructive dilemma to derive Q or S. The example is, if it rains, I will take a leave. If it is not hot outside, I will go for a shower. Either it will rain or it is hot outside. Correct? Therefore, I will take a leave or I will go for a shower. Next is destructive dilemma. If P implies Q and R implies S and negation of Q or negation of S are two premises, we can use destructive dilemma to derive this. Example, if it rains, I will take a leave. P implies Q. If it is hot outside, I will go for a shower. R implies S. Either I will not take a leave, negation of Q, or I will not go for a negation of S. Therefore, either it will not rain or it is not hot outside. So this is our rules of inferences as you have studied. So if you like our today video, please share with your friends, and if you are new on our channel, please subscribe our channel and like our video. Thank you very much.